So welcome to Design Workshop's guest expert learning session, Implementing Green Infrastructure, Weaving Natural Processes into Urban Streets Through a Green Infrastructure Continuum. We do these a few times a year. We do lots of internal learning sessions with experts that are our colleagues, and there are many. But a couple times a year, we invite a guest, which is really fun to kind of learn from others beyond the firm who are in allied professions. So it's my great pleasure to introduce Sarah Anderson and Colin Bell from the City and County of Denver joining us here today. I neglected to welcome our guests. We have a high number of guests today, which is just wonderful. Over 50 people from cities around the United States are joining us, which is really exciting to see, and a warm welcome to all of you, and hope everybody is healthy and staying safe. So just a bit about today's webinar. It will provide an overview of Denver's strategic and innovative stormwater program focused on green infrastructure implementation. With insights from the process of developing urban green infrastructure guidelines and the new Green Continuum Guide, Sarah Anderson and Colin Bell of the City and County of Denver Green Infrastructure Group will discuss how a greater suite of green infrastructure solutions can be used to transform the public realm and provide environmental, economic, and social benefits for all street users. When you signed up for the webinar, you, I'm sure, saw these learning objectives. Today, we will learn about the reasons behind the need for the Green Continuum. We'll learn about the methodology and modeling behind defining different levels of green. And we'll learn how the Green Continuum will be applied to city streets and capital improvement projects. So now I'd like to welcome again and introduce our two presenters, Sarah Anderson and Colin Bell. Sarah Anderson manages the Green Infrastructure Program for the City and County of Denver Public Works. She was hired in 2013 into a position that was new to Denver and has been partially responsible for creating and implementing a strategic and innovative stormwater program with a focus on green infrastructure implementation. With the creation of program metrics, Anderson worked to successfully secure $22 million of new funding for the Water Quality and Green Infrastructure Program over the next 6 years. She won the Public Works Employee of the Year Award in 2014 and the 5281 Mayor's Sustainability Award in 2016. Colin Bell is a professional engineer who's been studying urban stormwater quality facilities for 10 years. He is a senior engineering associate for Denver's Department of Transportation and Infrastructure. He provides the Green Infrastructure Program with stormwater modeling and engineering analysis to support data-driven policy and planning decisions. Colin is also interested in monitoring installed water quality facilities to assess performance, to improve future design and installation, and to quantify the community benefits of added green space. So it's a great privilege to have Sarah and Colin with us today to join our workshop where we engage in learning, often around conference room tables together, but not during this time. And since we're also practiced at learning from a distance, it was really quite seamless to shift into the last couple months of working from home. And we have staff and guests from all around the country joining today. So Sarah and Colin, I'm going to hand it over to you now.
Perfect. Well, thanks, Allison, and thanks to each of you for taking the time to learn a little more about Denver's Green Infrastructure Program, a little bit about where we've been, and hopefully more about where we're headed. It looks like there's about 115 people on this, so hopefully it's an interesting topic versus you're just stuck at home. So, but a little bit about us. The Green Infrastructure Group is housed in the Office of the Executive Director for DOTI. We've just recently switched from being a Public Works Department to a Department of Transportation and Infrastructure. So we are housed in the executive director's office in a group with a fairly awkward acronym of OPLASI, which stands for Office of Policy, Legislative Affairs, and Special Initiatives. The Green Infrastructure Group is, or GIG, which we think is slightly cooler than OPLASI, consists of myself, Colin, who you've heard a little bit on his background, along with Brian Wethington, who is a landscape architect. So we're a small but efficient group that is also heavily supported on any given day by a number of super smart consultants. The Green Infrastructure Group is mainly responsible for providing the direction for city decision-making on the green infrastructure policy, green infrastructure programs, plans, and even green infrastructure projects. So we'll start pretty basic with what is green infrastructure. I apologize if this is a little rudimentary for all of you, but green infrastructure is the use of, we refer to as living infrastructure, that uses vegetation, soils, and natural processes to manage stormwater and create healthier urban environments. Green infrastructure provides a host of benefits beyond stormwater management and water quality, but also improved air quality. It enhances our resiliency to climate change. It has a number of positive public health outcomes, including increased physical activity and mental well-being. And when done right, green infrastructure really can create a real sense of place. So today we'll really focus mainly on the stormwater management and climate resiliency benefits of green infrastructure, but know that there are many. I think one of the most misunderstood elements of green infrastructure is actually the scales of green infrastructure. Green infrastructure ranges from a single tree to site scale practices such as stormwater planters or rain gardens, all the way up to regional approaches, which include constructed wetlands and protection of floodplains, as well as a system of greenways. And so green infrastructure works on all these scales in Denver and likely everywhere in the world. Each one of these pictures are recent projects completed in Denver, ranging from kind of the site scale practices of the street-side stormwater planters on Colfax and Josephine to the planters on Brighton. We also show a sub-regional and regional facilities, one outside of a DPS school. And some of you at Design Workshop might recognize the aerial of the City Park golf course and the redesign in which Design Workshop played a giant role in that redesign. I find that people think of green infrastructure as only in those smaller practices and really kind of pigeonhole green infrastructure into this idea of just rain gardens or green roofs, but they really kind of fail to recognize kind of the flood control benefits of these larger regional scale green infrastructure systems. And despite all of the benefits of green infrastructure, we're losing it, I think globally, but certainly locally at a pretty alarming rate. Currently, Denver is 49% covered in impervious surfaces, 72% of which is untreated, meaning that 72% of the runoff from those impervious surfaces makes it to a nearby waterway without treatment. We've recently completed, well, in 2018, we completed a multi-year impervious cover forecasting model with CU Boulder that really projected the impervious cover change in Denver and forecast that it would grow from 49% to 61 to 67% by 2040. That's the equivalency of 8 square miles of new impervious area. Obviously, this would have tremendous impacts on stormwater quality and quantity, urban heat, vegetation stress, and certainly community livability. The Green Infrastructure Group is really focused now, we feel like the stormwater management story has been told and is fairly well understood, but we're currently focused on trying to better tell the story centering around urban heat. As Denver has the third worst urban heat island numbers in the country, it's not as noticeable here as in other places because of the nighttime temperature drop when the sun goes down. I guess one of many benefits of being a mile closer to the sun. But it's a problem, and it's going to continue to be a problem and become an even bigger problem with those projected impervious numbers that we showed on the previous slide. And so with the loss of green, you know, we lose all those benefits, the loss of vegetation's evaporative cooling powers, and really just the pure comfort of being in the shade. I mean, I've said this before, and I think in every presentation, but, you know, we all know the difference between not standing under a tree and standing under a tree, and how we feel and experience heat. And then we compound those problems because we replace the green with these heat sucking materials that trap heat at the surface and then radiate it back. And this heats up the environment. And then we cope with that, and our response to that is by turning up our air conditioners for those of us who are lucky enough to have those kind of systems and afford them, which then, you know, leads to greater fossil fuel production because that's how your air conditioner is powered, which leads to greater greenhouse gas emissions. And we end up in this giant negative feedback loop that we just can't seem to get ourselves out of. And we all know who live here in Denver, and I'm sure in every part of the country where people are representing, you feel it getting hotter. In Denver, we've seen a 2.5 degree increase in the last 50 years. And as you can see in the graph, by mid-century, we could have more than a month's worth of days over 95 degrees. And every time I say that, or I hear it, or I look at that graph, it's just real hard to believe that I'm saying that about Denver, Colorado. Next slide. And then, of course, with higher temperatures and warmer air, the climate change models also forecast more frequent and intense storms, followed by prolonged periods of drought in Colorado. More of our precipitation will fall as rain instead of snow. And our peak runoff has already shifted up to 4 weeks over the last 30 years and will continue to do so. And, you know, in our conversations with Denver Water and our collaboration, you know, that has a lot of impacts and logistical problems to be worked out for our water supply and our water storage system and how the reservoir system has been built. Next slide. And of course, we know that certain populations will be more vulnerable to the impacts, the climate impacts of increased heat and flooding. This story map represents heat, and it was created by the Denver Department of Public Health and Environment, which illustrates kind of Denver neighborhoods' vulnerability to extreme heat. And it shows kind of the interconnected socioeconomic, health, and environmental conditions. And those driving environmental conditions are tree canopy and impervious surface that really lead to this vulnerability. And we know the low income communities will feel the brunt of this, like most things. And because, you know, they lack access to parks or tree-lined streets, they have lots of impervious cover. They also lack access to transportation to get to places where they can cool off. The good news is that green infrastructure can really help mitigate the impacts of our warming climate. Tree canopy and other green infrastructure practices provide shade, which can block up to 70 to 90% of the sun's rays from reaching the ground. And then we also have evapotranspiration, sorry, I always have trouble with that word, is also at work. You know, leaves are little mini air conditioners, which, you know, kind of remove the heat from the air and evaporate the water. And, you know, we have trouble getting to the bottom of this number, but I've read it, you know, that this can really help reduce summertime temperatures by 2 to 9 degrees. And like I said, we've had trouble. We're also doing a little work just in the very early stages with CU Denver, who have some different numbers about what can be done from a degree standpoint. But we do some of our nearest planning efforts, or ones next up, are really to explore and do more research and modeling work around the cooling benefits of green infrastructure, and then the impacts of energy consumption based on those cooling benefits. Green infrastructure can also address the other big factor for Denver of climate change, which is precipitation variability. You know, green infrastructure can help manage stormwater by absorbing the rainfall and reducing flooding and peak flows. And then you could also design these systems with drought tolerant, thoughtful, native vegetation that should be able to withstand both extremes. By doing so, we also reduce our irrigation demands and hope to recharge groundwater supplies. You can see in the two pictures here on this slide of large-scale regional green infrastructure practices at work in Denver, kind of handling the precipitation variability. These pictures are of the Stapleton Greenway before and during the 2013 historic floods. Fortunately for Denver, the storm parked over Stapleton for about a week. I think it dumped about 11 inches of rain, but had it dumped or parked almost anywhere else in Denver, we'd have a much different story. But Stapleton was designed with these regional green infrastructure facilities to handle such an event. And so over the last 7 years, we've developed a number of planning initiatives kind of to elevate Denver's use of green infrastructure to not only manage stormwater, but also create a more resilient and equitable Denver. The first large planning effort we dubbed the scorecard. And the scorecard was developed before green infrastructure had any dedicated funding for a capital program. This data-driven effort kind of prioritized the basins in Denver most in need of green infrastructure based on a host of primary and secondary principles and data collection. And the primary principles were focused on stormwater quality and quantity, excuse me, while the secondary principles factored in things like park density, urban heat, and income levels. These kind of were all problems within the urban environment that we thought green infrastructure could address in some way. And so, we collected all this data, kind of threw it in a funnel, and came out with this heat map, which identified 6 of our highest priority basins, which are in the red, along with 5 medium to high priority basins, which are in the orange. And so the scorecard kind of told a story that if the program had money, we knew where we would invest it first and the benefits that could be achieved. And I'm proud to say that this map was pretty useful and was really shopped around with executive leadership and to city council. And it's what helped secure that funding that Allison mentioned in the beginning, helped secure a dedicated portion of the stormwater fee increase in 2015 solely for green infrastructure. And we are using that money currently to plan and design capital projects with a focus in these 11 basins first. And another planning effort that has been fairly successful was the development of the ultra-urban green infrastructure guidelines. When I started, Denver was kind of desperately in need of guidance for BMPs more suitable for tight urban spaces. A lot of the guidance centered around BMPs that were more suitable for development sites and certainly not linear transportation projects. So this guide identifies a number of BMPs that are really suitable for those areas. And through the development of this guide, I'm proud to say that we've completed, although we're a bit behind the times than the rest of the country, but we've completed our first green corridor on Brighton Boulevard. It has over 100 street side stormwater planters. And we also have another 300 or so, 300-ish street side stormwater planters, either in design or construction. And so together with the ultra urban green infrastructure guidelines in the scorecard, our next step was to create the green infrastructure implementation strategy. And this document really is kind of our master plan. And it focuses on those 6 red basins and the 5 orange basins. It's really the only basins we took to this planning level. And you can see the map on the lower right-hand side that really kind of identifies our regional opportunities. And so we worked in partnership with our Parks Department to identify parks that would be suitable for these more engineered large-scale green infrastructure practices. And then you can see the yellow kind of highlighted is where we've identified streets that are suitable for some of the practices outlined in the ultra urban green infrastructure guidelines. And this really is leading kind of how we prioritize our capital improvement program. And so, you know, through these previous planning efforts, we have been pretty successful and built a number of green infrastructure projects, both through our program and as a city over the last 5 years. We try, and I think we've been successful on each project thus far, to always have a partner, in particular a funding partner. So we've been able to really stretch that $22 million, and we have a lot more money dedicated to green infrastructure by doing so. However, as we build more of these projects, we find that they tend to be expensive. They're incredibly, the design costs are high. They take a great deal of time, both from the design and construction standpoint. They can still have some utility or space constraints that are hard to overcome in our urban environment, and often lead to this kind of all or nothing approach. So as a group, we've been focused about really thinking about simpler approaches and easier and cheaper to implement approaches that could more rapidly respond to our warming climate, because climate change is no longer, you know, if or when it will happen, it's happening. And so we want to ramp up our efforts. And then what's the best way to do that? And we kind of feel like, you know, not everything needs to be this highly engineered stormwater practice, that there might be some simpler approaches that are more practical and more usable across all of Denver. But the problem in part is these simpler approaches, at least in Denver, don't really have any stormwater value or criteria attached to them. And so since we are funded through a stormwater fee, we really need to be able to provide what those benefits are from a stormwater perspective. And so while we do that, we also want to do a better job of defining all the co-benefits of green infrastructure, so that we can really stand up a greater citywide approach to implementation of green infrastructure to address our warming climate. And so that's where Colin comes in. He's modeling the benefits of these smaller scale green infrastructure best management practices in a planning effort that we have dubbed this one the Green Continuum. So Colin, with that, I'll turn it over to you.
Yeah, thanks, Sarah. And right off the bat, Sarah sort of introduced this concept of green infrastructure working across and on all different spatial scales. And, you know, we always talk about the smallest scale is planting a tree, and the largest scale is sort of the whole greenness in the urban landscape. And, you know, sort of in between those scales, you know, we at the city, we have sort of 3 thrusts of things we can do. We can work on sites, we can work in streets, and we can work on regional projects. So those are sort of the 3 bins that we sort of think about green infrastructure, especially in terms of spatial scale. But, you know, as Sarah alluded to with all the stuff at the intro, you know, there are other scales that we can be using to measure and evaluate our projects and to help us select our projects. So basically down here is I have a bunch of other sort of scales that we want to measure and quantify to show how green infrastructure is working. So for example, stormwater performance. If you think about volume retained at the city scale, obviously a large regional pond with a ton of detention may seem to perform better than a tree at the city scale. But if you think about a smaller spatial scale, right, like if you're standing under the tree canopy and the tree is intercepting and evaporating all that water, then you sort of start to think about performance maybe a little differently. So within these spatial scales, there are all of these other scales. Another example, vegetation, right? You can plant a tree and hope it grows, or you can plant a tree and give it a ton of soil volume and make sure that it's the right species for the sun it's getting and make sure that irrigation is right. There's different sort of qualitative ways to plant the same tree. So that's sort of another one of these scales that exists in these green infrastructure projects. And then others that we think about are cost, the potential to mitigate local heat impacts, as Sarah talked about a lot, site context. So you can build a pond or you can build a pond that people want to go to, right? It's sort of the same thing in terms of hydrology and volume stored, but you have different other outcomes. And then other things we consider are equity, regulation or regulatory compliance or requirement is one we'll sort of talk a lot in the next few slides. And then partnerships. Some projects lend themselves to collaboration with other elements of the city than others do. And so to consider all these together, we sort of have this concept of the green continuum. And I sort of present it here kind of globally, and then we'll talk mostly about the green continuum as it applies to street projects. That's kind of the purview of the presentation today. So the continuum is shown in this figure here. And basically, as you move from left to right on this x-axis, we're moving from less, engineered practices or design practices to more design and more heavily engineered practices. So for example, the one we always like to use is, planting a tree would be a low engineering and low design practice, whereas building a street side water quality facility to full regulation with 9 inches of storage and 36 inches of media, that would be an example of our high end. And so what we want to do is sort of bend this continuum of engineering rigor into 5 bins, or what we're calling levels of green. So G1 on the left is a level of green 1, that's the least engineering. G5 on the right, level of green 5, the most engineering, and then levels 2, 3, and 4 fall somewhere in between. So then on the y-axis, we have a bunch of colored arrows which sort of represent project outcomes. So the first one in blue is our stormwater and water quality control. That's our first principle and sort of our, for the most part, our guiding, driving outcome. And so we think that, as you engineer more and more and you potentially provide more storage, more detention, and so on, moving from left to right, you see increases in hydrologic performance, but there's a chance that these increases may start to plateau, right? You can only store so much water before, you don't need to store any more water, right? The benefit has kind of been reached. But we also, as we said before, we still see that, even level of green 1, the stormwater benefit is non-zero. It's still there. So that's the first principle. The second principle is the dashed red orange color, and that kind of represents all of the other things that we want to achieve: heat reduction, climate change resilience, improved urban context, improved equity across the city, and public health benefits. And because a lot of these secondary principles are correlated with urban vegetation, urban forestry, urban canopy, the line in terms of the benefit may not look like the same shape as the stormwater line, right? So whatever of these engineering design principles that maximizes the canopy are probably going to be the ones that maximize these secondary benefits. And there's a pretty good chance that your fully engineered level 5 stormwater control measures, they don't necessarily maximize canopy as well as some other practices might. Third arrow is the gray arrow, regulatory compliance. We see this as binary. Some projects will have to meet a regulatory requirement, some may not. The way we're conceptualizing it now, levels 4 and 5 are in this regulatory requirement, 1, 2, and 3 are not. And then the final arrow, the green arrow, of course, in addition to green infrastructure, it also represents dollars. And the way we see it, you can plant a tree or a number of trees for a lot cheaper than it costs to design a full-blown regulatory water quality facility in which you have to dig up, 6 feet of the ground and move utilities and so on and so forth. And so the cost curve probably is also nonlinear across these levels of engineering. And so what we want to do is identify projects and sort of say, okay, that project is appropriate for a certain level. So, if there's no regulatory requirement and you really want to optimize heat reduction for the lowest cost possible, maybe a level 2 is what we want. And so what we really want to do is start to, categorize our design practices into these different levels. And ultimately, hopefully, these curves for now are sort of, just ideas. They're ideas of what they look like. We want to quantify these curves across these levels of green so that way we can really use this continuum rigorously on our city projects. So what I'm going to talk about today is sort of that exercise of drawing that arrow, that blue arrow for our first principle of stormwater, water quality, and hydrologic performance on our green continuum. So beginning to quantify and put numbers behind that arrow. So the way we see it is we can kind of start with design practices, things that we can do. And again, the continuum is going to apply globally, but we're sort of thinking about it in terms of streets and right-of-way projects for now. But what are some design practices we can include in our projects? Things like, how do we maximize our pervious area and include healthy vegetation? How do we minimize our directly connected impervious area in our design? And then finally, things like, how do we also provide some sort of storage? Maybe that's in the surface and sort of ponding storage, or maybe it's water storage in the subsurface and engineered media. And we sort of see that conceptually, we're moving from level of green 1 to level of green 5 as we kind of build out these different design practices. So the first part is to identify these things we can do. Then what we want to do is sort of quantify them as a site or project metric. So if we were curious about designing to maximize pervious area, well, then we'd quantify that with percent impervious cover on our site. We can quantify the percent of impervious areas that are directly connected to our drainage system explicitly. And then for the storage piece, the way we quantify storage provided is sort of relative to this concept of the WQCV, which is the water quality capture volume, which is basically the water quality regulatory requirement, in the Denver area and on the Front Range. It basically says, to meet compliance, you must store X amount of water for X amount of time. So we use these numbers to characterize our site and our project. And then what we do is ultimately look at these different projects and we quantify actual performance of the site. What is the hydrologic benefit of reducing impervious area or storing water? And we quantify performance by looking at annual runoff reduction volumes and the reduction of the 2-year peak flow. So this is kind of our quantification framework. And then again, the secondary principles, urban heat, resilience, and so on, that work will be forthcoming. Okay, so now even more specific, we did a modeling study to look at all of those quantities on the previous slide. And the purpose of the modeling studies was basically to look at our design practices and say, okay, these design practices fit into a given level of green, right? So we want to give a level of green for each of the design practices. So that's the first outcome. The second outcome is for all levels of green, even those that aren't regulatory, we want to show that they have value. They have hydrologic and community value. And as I said, this modeling study was done just for streets and the right-of-way, but we have some work that's similarly ongoing for private properties, which we call sites, and then maybe someday we'll build one out for regional projects. So what we did is we chose sort of a typical street cross section and a suite of design practices, and then for each of them, we quantified those performance metrics: annual runoff reduction, annual peak flow reduction, and we looked closely at the performance and we said, okay, how do these design principles separate, and how can we file them into our different levels of green? So this is an overview of sort of a plan view of the SWIM modeling that I did. So SWIM is the stormwater management model. It's an urban hydrologic model. But basically, we took a plan view of a typical street, so 400 feet long, and we're saying it's 40 feet wide. And we sort of turn that into a SWIM modeling environment. So, runoff from the road moves down towards the gutter, where it moves along the gutter until it reaches the inlet. Similarly, rainfall that lands on the walkway moves through the landscape zone of the stream to the curb and gutter, where it ultimately moves down to the inlet. And so what we can do with SWIM is systematically change the properties of this hypothetical road section so it reflects those site metrics and also reflects those design principles. So we can use it to represent our different principles. And then we ultimately assess how our different landscapes perform, en masse, the whole landscape together, by looking at flows into the drainage system. So the types of design practices we integrated into SWIM were, as mentioned, the first thing we did is we looked at different levels of impervious area. And so the way we were able to sort of conceptualize this in our typical street cross section is that our landscape zone, which is sort of highlighted here with the red parallelogram, our landscape zone could look a number of different ways. It could be completely paved, as in the image in the top left. It could consist of trees and tree grates. It could consist of trees planted in landscape islands that are not as small as the tree grates, but also not necessarily large, all the way up to a continuous, pervious tree lawn. And so basically we varied how vegetated our landscape zone is across this gradient, influenced by, forestry regulations and other sort of design standards in the city of Denver. So that's one thing we did. And the other thing we did is, in addition to varying the sort of footprint of the pervious area, we varied, I guess, the depth and the connectivity of that pervious area. So if you look at the dashed red line, that sort of represents a cross section in this right-of-way, and the cross section is what's shown in the diagram on the right. And essentially what we did is we tweaked this landscape area so that it existed at different elevations. So we look to see, okay, what if the landscape area is completely hydrologically disconnected from the walkway? What if it's, got a curb all the way around it and flow can't enter? Okay, what if we put this landscape area at grade with the walkway? So that way, lateral flows could flow in, but there's no storage, so it would flow out on the other side. What happens if that landscape area is a little bit depressed, maybe 2 inches depressed, maybe 4 inches depressed? How does that affect our runoff? And then also we looked at depressing it so much such that flow from the drive or the actual street could also enter the landscape area. What if the elevations were, equally at level or were level, so that way flow would kind of flow in and out of the landscape area? What if we provided 2 inches of storage, 4 inches of storage? all the way up to what if we provide enough storage so that basically our landscape area is now a fully engineered, a street side stormwater bioretention facility that meets engineering, design guidelines. So sort of a range of both the footprint of the impervious or the pervious area, as well as the depth and the connectivity. And so ultimately, we had a bunch of model simulations, which are shown here on the left. And basically each one of those bar plots represents a different configuration of our pervious landscape area and its depth relative to the other areas in the road. And we quantified basically over 10 years, what was the actual, or what was the modeled reduction in runoff. And by looking at these different interventions, we were able to sort of start to now parse out what are the things that we can do that define different levels of green. And so that's kind of what you see over here on the right. It's sort of a synthesis of all of those bar plots into sort of conceptual levels of green. So for example, the first level of green at the top, G1 in gray, if we maximize our vegetated pervious area in the landscape zone, we can expect runoff reductions around 5 to 10% and peak flow reductions around 5 to 15%. So that's our design principle for level of green 1 and the expected performance. Now for level of green 2, if you start to connect your walkway to that pervious area, you see that your performance in terms of runoff and peak flow jumps. Now we're 5 to 30% for runoff, 5 to 40% for peak flow. So that's level of green 2. Level of green 3, if you start to introduce roadway flow into your pervious area, if you keep it at grade, you can see runoff and peak flow reductions around 30%. But if you provide some level of storage in that pervious area, even if it's 2 or 4 inches, your runoff and peak flow reductions jump a lot. So between level 2, which is pervious area, collecting water from the walkway or the sidewalk only, to level of 3, where now we're introducing roadway flows into this pervious area, we can see sort of large jumps in performance. And the last two levels of green, level of green 4 and 5, are centered around storage and detention of a percentage of that water quality capture volume. So we picked 60% for our level of green 4 for storage, and then level of green 5 would be the full regulatory storage requirement. And here are the last charts, so appreciate you bearing with me, but we didn't really intend to look for this, but while we were looking at these levels of green, this sort of interesting thing kind of came out of our results. And so we have shown here is sort of a synthesis of those bar plots. And on the x-axis, we're showing, okay, what percent of our regulatory volume are we storing? And then on our y-axis, it's kind of what are our benefits. So the left panel is what's our peak flow reduction, and the right panel is what's our overall annual runoff reduction. And what we found is that for peak flow, the more volume you store, you can expect sort of a linear or a proportional increase in the benefits to peak flow. But for runoff reduction, we didn't see that. What we saw is that basically the curve isn't a straight line. It tends to saturate. And so what this tells us is that, okay, if you store 20% of your volume, if you have the ability to store 60% of your volume for maybe not that much more of a capital investment, it's worth doing because you'll see a substantial increase in performance. However, the difference between storing 60 and 100% isn't as drastic. So maybe taking that step and building in more storage isn't necessarily as valuable. And then another thing that came out of the work is just that when you build these bioretention, or we call them street side stormwater planters with under drains, we find that obviously because they're drained and the drains typically go to the storm network, your actual runoff reductions are a lot lower because the under drains are collecting this water and there's less chance for infiltration. Okay, so that's how we quantified and the stormwater principle of the green continuum. Now let's talk about how we are and plan to apply the continuum to our streets. So the first was for city capital projects. And we're currently developing these guidelines, which you can see 3 screenshots from here on this slide, which basically tell or hope to tell people within the city looking to build a green street that maybe doesn't have to meet regulatory requirements, how they might do it. So you see an example here of the level of green 3, which receives runoff from the street and the drive. And so these guidelines are going to tell people at the city how they could design these so that they work and provide those benefits that we predict with the modeling and that our green continuum is sort of showing. And the purpose here would be, there could be 2 potential applications. One is that our program, the Green Infrastructure Program, we could specifically set out to fund the construction of these facilities throughout the city. Another is that if there's another right-of-way project going on and the project is interested in doing green infrastructure, they now have this resource available to build a level of green 2 or level of green 3 that they can give to their consultants. So our plan is to get some of these installed with capital dollars and build them and monitor them. And if we see that, hey, these are really working and we feel really confident about them, then eventually turn it into some kind of policy where, city projects are not just opting into building a level of green 3 flow through planter. They are required to, potentially. That's down the road though. And then here are just some examples for the way that we would like the streets in Denver to look. On the left, there's pictures from throughout the country and throughout the world of how we see these facilities. In some cases, they're vegetated areas just receiving flow from the sidewalk, but sometimes they're recessed and receive flow from the streets. And we think that's better hydrologically, but we're still happy if our streetscapes are green and pretty and people have a place to sit and so on. And we hope to, in Denver, the Mile High City, we have this planning conceptual project that's a 5280 loop, and it's a somehow conveniently engineered 5.28 mile basically connectivity corridor that links different downtown Denver neighborhoods. And this is an example of a project that, there's going to be a lot of people on there. It probably won't trigger regulatory compliance, but that doesn't mean that we shouldn't, build in green infrastructure so that it can provide all of the stormwater benefits that we're showing and all of the urban context and urban heat and resilience benefits that we also expect. That's one potential use of the continuum for projects, street projects, and we also see it as a really good planning tool. So basically what we can do is look at all the streets in the city, and let's say, for example, there's a neighborhood that has a large regional facility downstream, but it's plagued by urban heat. Well, this would be a neighborhood that's really good for levels 1 and 2 interventions, those that really increase the canopy and provide some stormwater benefits, but maybe that's not the primary outcome. And then there could be other neighborhoods in the city that have real dirty water and there's no regional facility and they could be close to the South Platte River. And so maybe these are streets that are better candidates for, levels 4 and 5 designs that are really bomb-proof water quality treatment devices. We also see this as a tool to help us spread our program budget further. So here I have sort of a comparative example for a level of 2 versus a level of green 5. And so sure, the modeling maybe showed that, a fully engineered stormwater planter, let's say it treats runoff, 3 times better than our level 2 design concept, right? So if that were the case, then it would take 3 miles of level 2 streets to give the benefits of 1 mile of level 5. But if you think about something like canopy, the shoe could be on the other foot there, right? If we're planting more trees on a level of 2 than we can in our engineered facilities for level 5, then maybe, the relationship's the opposite. And so, also if level of 2 designs are a lot cheaper than a level of 5 design, if we can build 10 miles of level 2 for the cost of 1 mile of level 5, maybe we should do that. Maybe there are places that we will. And then the final planning application that we see is, being able to have a map of these levels of greens in all of our streets. It'll help us to overlay with other city projects if there's paving plans, if bike lanes are going in, and so we can kind of easily identify project partners. And then also, if there's another linear right-of-way project going on, maybe our continuum will convince them to fund their own, construction of a green street at a level of green 2, because we've shown that, hey, look at all these benefits, and look at how much it costs. Maybe you want to fund it yourself. That's the real dream. So one more thing here is, we as a program, we've had this goal of 25 miles of green streets for a couple years now. And basically what that means is, we look at a typical right-of-way and we say, okay, how much, area is in 1 mile of a typical right-of-way? And we say that, okay, for every time we can treat that amount of area with our street side green infrastructure, we give ourselves credit for accomplishing 1 mile of green, right? So if we can treat 8.24 acres of right-of-way with a planter, then we say, okay, we've achieved 1 mile of green streets. And so we have this goal of 25 miles of green streets in 5 years. And that was adopted by the city engineer. People are really excited about it. But what we found, if you look at this chart here, is that basically we've been doing this since 2018, and we're super proud of what we've got done, but we're only up to 5 miles of green streets. And part of the reason is that just very costly and very difficult to provide full regulatory control to meet this goal. So the way we see it is the continuum. It's also a tool for us to meet this program goal of 25 miles of green streets, if we acknowledge that, hey, a green street doesn't have to look like a street with deep planters. It could just be a space with green trees. And so finally, I spent a lot of time talking about quantifying that blue arrow, that first principle of stormwater. But we also, in the near future, want to quantify other things. Sarah mentioned partnering with a local university to start to quantify the actual heat reduction benefits of our urban canopy, working with other offices in our Department of Transportation and Infrastructure on putting better numbers around or more thoughtful information into our equity planning, and then ultimately trying to build in livability and site context design principles into the continuum. Okay, and with that, I will wrap up. Here's our contact info. I think Allison is going to triage some questions. I know we're almost to one, but we could probably take.
Fine. This is great. Thank you so much, Sarah and Colin. Yes, we do have some questions coming in, so I'll just dive in and start to share some of those. And of course, we will capture all of these in case we don't get to everyone, and we'll get back to you. One of the first questions is, do you have metrics on the ROI for bioswales and rain gardens on public streets in terms of water quality improvements, heat island reduction, and improved human comfort and change in real estate values?
The short answer to that is no. We don't have the return on investment, certainly from the heat island or some of the other things you mentioned. The only thing that we've done thus far is we do have a monitoring program, so we understand for the street side stormwater planters, we've currently testing 2 of our new sites, one on Brighton Boulevard and one at 21st and Broadway, to understand more of the stormwater metrics. But that is something that we're trying very hard to at least set up the next steps of how we can start to have metrics associated with the co-benefits of green infrastructure.
Okay, another question is, did you look at pervious pavements in the streets? And a follow-up from the same person that was related was, do your volume curves tell you that you don't have enough area to treat the runoff? Thus the question about pervious pavement with storage under the street.
Yeah, we did. I'll answer that one. We did do all those same simulations with, uh, pervious pavers in the walk zone and in the full street, and then maybe even just a pervious bike lane. And so we did look at that, and we do have estimates of how well they work. They're sort of the theory behind that modeling was it was sort of all a regulatory situation. Like we didn't really know of how to design a permeable paver that was sort of less than regulatory, and so that was sort of all in our mind a level of green 5. And another thing that I'll add is with this green continuum modeling, we really do want to get more vegetation in. And so we did do the modeling and we thought about it, but we left it off here because it's not really vegetation and green centric.
Okay, another question. There's actually two kind of related to maintenance. How do you deal with snow removal in open bioswales and rain gardens in terms of design or maintenance? What are the best practices you've learned in your initial GI projects? And then there was a related question about, sorry, just looking through here. Who is responsible for maintenance and how is that being funded? So two kind of maintenance related questions.
Oh, maintenance. I don't think we have enough time left for that question. Snow removal, thus far, we have not, except for Brighton is the one example where this is not true. As we intentionally didn't put our first facilities kind of on our arterials, which is what we plow and what we use de-icer on. I would say Denver's, thus far, I haven't seen a lot of problems with the snow removal because we have a powerful tool in our department, which is the sun, and being so close to it. And I think everybody here in Denver understands, we can get a pretty significant snowstorm and there's no evidence of it 2 days later. Now, that was not true this last winter where we had that 2 weeks, but unlike the East Coast where I lived for a number of years where you push the same snow around for many months, we don't suffer from that. So we don't have as big a snow removal problem, I think, as other municipalities. And again, that being 1 o'clock, I'm happy to answer some maintenance questions. It's a difficult road, that's for sure. We do some of our maintenance through like a MID, BID on Brighton. We have an outside contract that we did with Parks Department for their median contracts. We put our first few projects out of the gate on that contract so that they would be maintained from a trash and inlet cleaning, ensure that they function. And currently most of our stuff still has a vegetation warranty, but many of that will expire. And then our group and the wastewater operations team, we meet every 2 weeks and we're setting up a maintenance program as we speak that will take over the maintenance of all of these facilities in 2021.
Great. There's a couple questions related to salt and its impacts on plants in GI projects, especially urban streetscapes. How does the use of salt affect water quality and efficiency of GI systems?
I think that we unfortunately can't answer a lot of these kind of long-term questions yet. Brighton Boulevard was our first green corridor, as I mentioned, and it opened 2 years ago. We have a project at 21st. Anyway, I won't go through the projects, but we are monitoring those things, and through the standing up of this maintenance program, we're also going to do a better job tracking plant health and plant survivability. Thus far, we've not seen a lot. I've been pleasantly surprised because I was a little nervous about, as Brian pointed out to me one day at a meeting, he's like, we just went all in on Brighton, just a large number of facilities at once. And I was like, oh God, I never thought of that. But I've been pleasantly surprised at the vegetation establishment And so we haven't seen a lot of the decline from the de-icers yet, but I think that's something you more learn, over time. But we are monitoring them, so we should have some answers to that in a few more years after, most of our projects are fairly new, unfortunately.
Okay, there's a few more questions if we're okay continuing. One is a challenge to implementing GI or blue-green systems is often the collaboration and alignment of policies and priorities among engineers, foresters, park planners, public works, transportation, and maintenance. Are there any techniques for collaboration that you have found most effective for implementing an integrated GI project? Are there ones that are more effective at the G1 level versus a G5 on the green continuum?
Right. Well, keep in mind that continuum is still very much a planning effort. It has not been implemented within Denver currently. We're just trying to assign values to the different levels of green before we actually put it into practice. So it is very much a planning level effort. We have been very successful at our collaboration, and there's a number, I think, reasons for it. I think how do I say this? The employees in the Denver Parks Department and the waste, we all share similar values. In a way, we all want to make Denver a better place to live. We, want to have places to recreate. We want our, the bicycle program is very progressive. People understand that people don't want to bike down streets without vegetation, and so we all realize that, green infrastructure, and we've done a lot of messaging around that green infrastructure does make safer connections. It does make, used to be anyway, fairly avid commuter on my bike, and I knew the streets that had trees. The sun's intense here, you got to get under the shade. And, and so we all kind of collectively know that these shared benefits we have, and then we had to prove, and we spent many years doing this, prove how green infrastructure did make safer connections, did make communities more livable, did get people out of their cars, does provide stormwater management, so a lot of it is really going after your city's goals and targets and showing how green infrastructure can help them achieve that is kind of the approach we've taken, I believe.
There are a couple questions related to cost. Can you summarize the cost relationships with the continuum? Another one that said, what's the percentage of additional cost for GI streets when compared to a typical street?
Colin, I don't know if you know those numbers offhand. We're certainly there's a cost impact, and that's part of the reasoning behind the continuum. A big reason is we're, like Colin kind of mentioned, we can do 1 mile of Brighton level street side stormwater planters at X cost, or we can do 5 miles at that same cost. And then how do we compare those benefits? You get 5 more miles of people being able to have tree-lined streets and those kind of things. So, and we have costs for our projects. We can certainly share a square foot cost with whomever is interested. Part of our I don't know if it's reluctancy, but we have been successful at not doing any project by ourselves thus far. So we have a lot of shared costs in concrete and mobilization and erosion control and all those things. That sometimes it doesn't give the full cost of what the practices are, but we certainly have costs we can share with whomever's interested. I don't actually have the numbers in my head offhand. I don't know if you do, Colin, on a square foot. Brian is really our landscape architect, tracks those costs in a spreadsheet for each of the projects.
We'll definitely feel more confident sending a number than misquoting it, for sure.
Right.
Okay, well, we can track who that came from and share some of that information. I think since we're over our time, maybe we'll just end on one more question, which is, can you share more about where you're heading for equity and green infrastructure? Are there goals to create more partnerships or to better prioritize efforts?
Absolutely. We, during the initial scorecard effort, we tried to take a stab at equity, and it was before the city had really stood up an equity program, and all we really knew what to do was look at income levels. Our boss is James Fisher, who's the chief of staff, and he is incredibly focused, as is the city as a whole, on this equity piece. And since our original planning efforts of the scorecard, there's now an equity index for the city. There is a number of people working on that. And so we just feel like, I'm certainly no expert by any stretch of the imagination on that, but I am going to pull in the experts. And that's where, part of the continuum too is we can stretch these dollars to get more green infrastructure in the neighborhoods that most need it, which are those neighborhoods that historically have failed to get the same amount of infrastructure, whether it be green, whether it be sidewalks, whether it be schools. All the maps of equity kind of overlay the same a little bit. And so that's one of the main reasons behind the continuum, is that we can hit more of these neighborhoods faster so that they can not, so the climate change isn't as hard on them as it will be if we don't do anything.
Well, thank you so much, Sarah and Colin, for sharing your expertise, your presentation, and the follow-up responses to the questions. As I said, we're capturing these questions, and I'll share them with Sarah and Colin to see if there's any follow-up. Really appreciate everybody joining today. We had a very high number of people, I think one of our records, so that'll be interesting to see what the final numbers are. Thank you also to all of our guests who joined, and of course to DW's staff, who are used to doing this a few times a year, but it's really fun to extend the invitation beyond our workshop and really just enjoy the partnership and the allied thinking with Sarah and Colin.